Beneath the silence of modern Earth, there are landscapes that no human memory has ever fully known, coastlines now buried under oceans, green deserts that once held lakes, and stone formations that sometimes look almost intentional. But as we trace these worlds deeper into time, a strange question begins to form, not about what we remember, but about what time itself has erased. Before we go further, take a moment to like the video and subscribe if this kind of slow, immersive history is what you enjoy. It helps support the channel and brings more long-form journeys like this to you. Because tonight, we're not just looking at history as we know it, we're following the traces of Earth's forgotten past and asking whether everything we think we know about early worlds is really the full story or just the part that survived. The wind moves across a landscape that does not belong to any human memory, a stretch of stone and dust shaped long before names existed to describe it. Beneath the surface, layers of time sit pressed together like pages in a book that no one can fully read. In certain places, the rock breaks in ways that feel almost deliberate, lines intersecting at angles that briefly suggest order rather than chance. For a moment, it becomes easy to imagine something once stood here, something structured, something familiar. But the deeper the view goes, the more the Earth resists that idea, as if reminding us that not every pattern is a message. Far below modern soil, in strata formed hundreds of thousands or even millions of years ago, the planet keeps its own record of vanished worlds. These are not civilizations in the human sense, but ancient environments, shifting rivers, vanished lakes, forests that grew under skies no longer recognizable. Yet when fragments of these worlds are uncovered, they sometimes appear unsettlingly arranged. Stones align in near-straight sequences. Minerals crystallize in repeating forms. Erosion sculpts shapes that resemble tools or walls until closer inspection reveals the patient hand of water and pressure rather than intention. Still, something about these deep time remnants continues to invite interpretation. Human minds are built to recognize patterns, to search for meaning even in randomness. And so, across decades of excavation and geological study, there have been moments when natural formations were briefly mistaken for something more deliberate. A fractured basalt column might resemble a carved pillar. A cluster of mineral deposits might look like the foundation of a forgotten structure. Each time, further analysis returns the explanation to geology, not architecture. Yet the initial impression lingers in the imagination. It is in this space between perception and evidence that the idea of forgotten civilizations before humanity begins to form not as confirmed history, but as a reflection of curiosity. What if, the mind wonders, something existed so far back in time that its traces were almost entirely erased? What if the Earth has already hosted complexity that predates humanity by millions of years, leaving behind only ambiguous shadows in stone? Before that thought can settle, the scientific record quietly pushes back. The known timeline of life on Earth is vast, but it is also structured. Microbial life dominates its earliest chapters, followed by the slow emergence of multicellular organisms. Then the long rise of fish, plants, reptiles, mammals, and eventually hominins. Nowhere in this sequence is there evidence of technological civilization predating humans. No undisputed artifacts, no engineered materials, no clear signatures of industrial activity buried deep in ancient rock layers. The silence is not absolute, but it is consistent. And yet, the Earth is not a perfect archivist. It is a destroyer as much as it is a recorder. Plate tectonics recycles crust, erosion erases landscapes, Ice sheets grind continents into new shapes. Entire coastlines disappear beneath rising seas and falling temperatures. Over immense spans of time, even large structures would be reduced to indistinguishable fragments. This is where the scientific caution begins to meet the imagination again. Absence of evidence is not always evidence of absence. But in geology, absence often has a physical explanation. Before going deeper into these possibilities, it is worth pausing on something quieter. If this is the kind of history and mystery that draws the mind in, take a moment to like the video and subscribe. These long journeys into Earth's deep past unfold slowly, and each step reveals how much of reality is still hidden beneath layers of time. Back in those ancient strata, what is most often found are not ruins, but processes. Sediment flows like water frozen in motion. Volcanic ash settles in rhythmic bands. Ancient riverbeds carve patterns that later harden into stone, preserving movement itself rather than structure. To an untrained eye, these can resemble design. To a trained geologist, they tell a different story, one of pressure, temperature, and time acting without intent. Still, there are moments when even experts pause, not because they suspect lost civilizations, but because nature occasionally produces configurations that feel counterintuitive. Concretions form near-perfect spheres within sedimentary rock. Crystal growth produces repeating geometries that seem almost engineered. Weathering can isolate pillars of stone that resemble carved monuments. These formations are not rare in geological terms, but they can be striking enough to invite questions from those encountering them for the first time. What makes these moments powerful is not what they prove, but what they suggest about perception itself. The human brain is constantly negotiating between randomness and meaning. It prefers structure, even where none exists. This tendency has been essential for survival. But in the context of deep time, it can create illusions of intention where only natural forces are at work. Even so, the fascination persists. The idea that something might have existed before humanity, in a form resembling civilization, is not supported by evidence, yet it continues to appear in stories, theories, and reinterpretations of ancient landscapes. Part of this persistence comes from the scale of Earth's history. When compressed into a single human lifetime, geological time becomes almost incomprehensible. Millions of years pass like breaths. Entire epochs vanish between one heartbeat and the next. In that vastness, it becomes easier to imagine gaps, missing chapters, lost worlds that left no clear trace. But science fills many of those gaps with careful reconstruction. Fossils reveal ecosystems. Isotopic analysis reveals climate shifts. Magnetic signatures in rock reveal continental drift. Each method narrows the space where speculation can exist, not by eliminating mystery, but by organizing it into known processes. Still, the sense of something just beyond reach remains, not because evidence points toward hidden civilizations, but because Earth itself is so dynamic that perfect preservation is impossible. Every layer of stone is both a record and a transformation of what came before. In that constant rewriting, earlier chapters become harder to read, and interpretation becomes more tentative. As the landscape continues to erode under wind and time, it becomes clear that the story of the planet is not one of static records, but of continuous change. What survives is not what was complete, but what was resilient enough to persist in altered form. And in that survival, the line between what is known and what is imagined sometimes feels thin, even if science consistently anchors it back to observable reality. The deeper this journey begins, the more it becomes less about lost civilizations and more about the act of looking itself how humans search ancient stone for meaning, and how the earth, indifferent and immense, continues to reshape every answer into something slightly less certain than before. Beneath the surface of continents, the earth holds a kind of memory that does not think, but records with stubborn precision. Layers of sediment accumulate slowly, grain by grain, as rivers shift their paths and seas retreat and return. Each layer traps a snapshot of a world that no longer exists, sealing away fragments of climate, life, and landscape in a form that can survive deep time. Yet what survives is never complete. It is always partial, always filtered through pressure, heat, and movement that reshape everything it touches. When geologists cut into these layers, they are not looking at scenes from a frozen past in the way a photograph preserves a moment. Instead, they are reading distortions, compressed histories, rewritten by physical forces that do not preserve intention, only consequence. A mudflat becomes shale, a forest floor becomes coal, a desert dune becomes sandstone. In each case, the original form is erased even as its essence remains. This is where misunderstanding often begins. Certain rock formations, when exposed after millions of years, can appear structured in ways that resemble walls, floors, or constructed environments. Natural fractures can form grids. Mineral veins can trace sharp lines through stone. Erosion can isolate blocks that look like deliberately placed stones. In rare cases, entire cliff faces erode into shapes that feel almost architectural. But beneath every example lies a consistent explanation. Pressure gradients, water flow, crystallization, and time acting without purpose. The Earth's processes are not random, but they are indifferent. They do not aim to create meaning or avoid creating illusions of meaning. They simply follow physical laws, and yet, to a mind searching for patterns, indifference can sometimes look like design. This is why the study of deep geological time requires both precision and restraint. The more one understands the mechanisms involved, the less room remains for accidental interpretation. Still, the scale of time involved is so immense that it naturally invites imagination to wander. Tens of millions of years separate us from many of the rock layers we study. Entire mountain ranges have risen and eroded since those layers formed. Oceans have opened and closed. Continents have drifted across the planet like slow-moving rafts. In that kind of movement, even the most durable structures would be dismantled beyond recognition. The oldest known rocks on Earth date back more than 4 billion years, formed during a period when the planet itself was still cooling and stabilizing. In those earliest eras, life existed only in microbial form, clinging to hydrothermal vents and shallow seas. There were no ecosystems capable of supporting anything resembling civilization. The chemical conditions simply did not allow it. Oxygen levels were low, land surfaces were barren, and the atmosphere was hostile to complex life. And yet, despite this clear scientific framework, questions persist about whether something might have existed before the known timeline of civilization. These questions do not arise from evidence in the strict sense, but from the gaps in human perception. When vast stretches of time are difficult to visualize, the mind sometimes fills them with possibilities that feel plausible simply because they are difficult to disprove completely. Modern science addresses this not by assuming absence, but by searching for signatures. Civilization, as understood in archaeological and anthropological terms, leaves behind specific markers. These include modified materials, concentrated energy use, chemical anomalies, and distinct isotopic patterns that differ from natural geological processes. So far, none of these signatures appear in rock layers older than human evolution. Even so, Earth does preserve unusual formations that occasionally spark curiosity. In some regions, naturally occurring nuclear fission reactions have taken place deep underground under very specific conditions, leaving behind altered isotopic ratios. In others, mineral deposits form structures that mimic organized repetition. These phenomena are rare, but they demonstrate that nature is capable of producing complexity without intelligence. What is often overlooked in discussions of deep time is how much has been erased. Glaciers have scraped continents clean. Rivers have shifted thousands of times. Volcanic eruptions have buried entire landscapes under ash and lava. Tectonic subduction has dragged ancient seafloors back into the mantle. In this constant recycling, the Earth does not preserve history in a linear archive. It transforms it continuously. Because of this, even genuine ancient environments are often reconstructed only in fragments. A fossilized footprint might reveal the presence of a species, but not the full context of its behavior. A pollen grain might reveal vegetation, but not the shape of the forest. A sediment layer might reveal a flood event, but not the experience of those who lived through it. The deeper the timeline, the more abstract the reconstruction becomes. This abstraction is where imagination sometimes steps in too confidently. The idea of lost civilizations before humanity often relies on the assumption that complexity must leave visible ruins. But geological processes ensure that visibility is temporary on cosmic timescales. Even mountain ranges are not permanent. Given enough time, everything becomes sediment again. Yet despite this inevitability, there is a boundary that remains firm in the scientific record. There is no verified evidence of technological civilizations existing before humans. No manufactured alloys in Precambrian rock. No artificial isotopic signatures embedded in ancient strata. No structures that withstand scrutiny under multiple independent analyses. The silence is not philosophical. It is measurable. At the same time, science does not close the door on mystery entirely. It simply defines where mystery can reasonably exist. There are still unknowns about Earth's earliest life, about how quickly intelligence emerges under different conditions, and about how rare or common technological civilizations might be in the universe at large. But within Earth's own recorded layers, the story remains consistent. What remains fascinating is not the idea of hidden civilizations, but the Earth's ability to blur the line between natural and artificial appearances. A fractured basalt formation in Iceland can resemble ruins. Eroded sandstone in the American Southwest can look like carved architecture. Salt flats can form geometric patterns visible from above. These are not mistakes of nature, but expressions of it. Each of these formations serves as a reminder that perception is not the same as origin. The human mind interprets structure as intention because that is how it navigates the world. But in deep geological time, intention is not required to produce complexity. Pressure, heat, and movement are sufficient. As the view shifts deeper into the planet's layered memory, it becomes clearer that what is preserved is not a record of civilizations before humanity, but a record of a planet in motion, a planet constantly reshaping itself, erasing its own past while simultaneously preserving fragments of it in transformed form. The deeper one goes, the more the Earth appears not as a repository of a lost human-like worlds, but as an ongoing process that makes permanence impossible. And in that realization, the mystery changes shape. It is no longer about what might have been hidden beneath time, but about how little time allows anything to remain unchanged at all. Long before the idea of civilization can even begin to take shape, the Earth is already crowded with life that would look unfamiliar to the modern eye. Shorelines shift under different skies, forests spread across continents that are not yet fully recognizable, and early mammals move quietly through landscapes still dominated by reptiles in earlier chapters of deep time. In this world, intelligence exists, but it has not yet taken the path that leads towards cities, writing, or technology. Everything's biological, adaptive, and shaped entirely by survival. The lineage that eventually leads to humans begins here, not as a single straight path, but as a branching network of hominins and earlier primates experimenting with different ways of living. Australopithecines walk upright but still rely heavily on trees. Early Homo species begin to develop more refined tool use, shaping stone into sharp edges for cutting and scraping. Later forms, such as Homo erectus, expand their range across continents, carrying fire and simple tools, learning how to adapt to environments that shift with climate cycles. Even at this stage, the idea of civilization is far beyond reach. There are no permanent settlements in the modern sense, no large-scale agriculture, no written systems, and no accumulation of architectural knowledge across generations. What exists instead is a slow accumulation of behavioral adaptation. Groups learn to track animals, to recognize seasonal patterns, to exploit resources when available and move when they are not. This long prehistory often gets compressed in popular imagination, but in reality it spans millions of years. During this time, Earth undergoes repeated climate oscillations. Ice ages advance and retreat. Sea levels rise and fall. Habitats expand and contract like breathing systems on a planetary scale. Each shift forces early human ancestors to adapt or disappear. Many branches of the hominin tree do disappear entirely, leaving no descendants. Despite this richness of life, there is no evidence anywhere in this timeline of technological civilization. No signs of metallurgy beyond simple fire use, no large engineered structures, no complex energy systems, and no persistent urban environments. The archaeological record, even when stretched across continents and millions of years, remains consistent in this regard. Still, the fascination with lost civilizations before humanity often draws attention to artifacts and formations that appear ambiguous when taken out of context. A naturally flaked stone can resemble a tool until microscopic wear patterns are examined. A rock fracture can look like a carved edge until geological processes are understood. Even intentional early tools can sometimes be misinterpreted when found in isolation, without surrounding evidence. Archaeology addresses this ambiguity through context. A single object means little without its surrounding environment. Stratigraphy, the study of layered deposits, helps determine whether an object has been disturbed or remains in its original position. Use-wear analysis reveals whether a stone was actually used as a cutting tool or simply fractured naturally. These methods gradually reduce uncertainty, even if they cannot eliminate it entirely. One of the most important realizations in studying early hominins is how fragile the record truly is. Organic materials rarely survive beyond certain timescales unless conditions are exceptional. Wood, fibers, skins, and even bones degrade unless quickly buried under protective sediment. This means that much of early human life is invisible to us. We see only the durable fragment stone tools, teeth, and occasionally footprints preserved in ash or mud. This fragility often leads to misconceptions. If only stone survives, it can be tempting to imagine that only simple stone-based cultures existed. But anthropologists know this is not the case. Even early human groups likely used wood, plant fibers, and other perishable materials extensively. The absence of evidence is not absence of complexity, it is a result of preservation bias. Even so, this preservation bias does not extend far enough back to suggest hidden technological civilizations. The deeper one goes into pre-human strata, the more consistent the absence becomes. There are no anomalous concentrations of refined metals, no artificial composites, no structured industrial residues embedded in ancient geological layers. What does appear, instead, are signs of life evolving under changing environmental pressures. Fossilized bones show gradual anatomical shifts. Tool traditions evolve slowly across thousands of generations. Migration patterns follow climate corridors that open and close over time. Everything fits within a biological framework rather than a technological one. Occasionally, natural formations can still create confusion for those encountering them without geological training. Flaked rocks produced by pressure and temperature changes can resemble human-made tools. Concretions can form shapes that appear deliberately shaped. Even fractures caused by tectonic stress can mimic patterns that look intentional. But under detailed examination, these formations reveal their origins in physics rather than design. This is where the boundary between imagination and evidence becomes especially important. The mind is quick to recognize familiar forms, even when they arise from unrelated processes. This tendency is known in cognitive science as pattern recognition bias, and it plays a significant role in how ambiguous archaeological or geological finds are interpreted by non-specialists. Scientific methodology exists partly to counteract this bias. Multiple lines of evidence are required before a conclusion is accepted. Radiometric dating establishes age. Microscopic analysis determines usage. Geological context confirms whether a site has been disturbed. Only when these independent methods align does an interpretation become reliable. Through this careful process, the picture of early human existence becomes clearer. It is a story of adaptation, migration, and survival across shifting environments, not a story of forgotten advanced civilizations. The absence of technological signatures in pre-human layers is not a gap waiting to be filled. It is a consistent pattern supported by multiple fields of study. Yet even as the evidence becomes clearer, the imagination continues to search for deeper layers beneath it. The idea of civilizations before humanity often reflects not the data itself, but the human desire to extend meaning backward into the vastness of time. When millions of years feel difficult to comprehend, the mind naturally compresses them into narrative forms that feel more familiar. But the Earth does not preserve narratives, it preserves processes, and within those processes, life unfolds in gradual, continuous transformation, rather than sudden leaps into complexity. Civilization, as it is known today, is a very recent development in that long chain. As this long prehistory continues to unfold, it becomes increasingly evident that the real story is not about what civilizations might have existed before humans, but about how extraordinary it is that civilization emerged at all within such a narrow slice of time. In a wind-scoured desert or beneath layers of forest soil, the ground sometimes reveals shapes that seem almost too ordered to be accidental. Lines intersect at right angles. Stones appear stacked in sequences that suggest intention. Even fractured rock can sometimes resemble the remnants of collapsed walls. It is in these moments that the boundary between natural formation and human interpretation becomes fragile, especially when seen without context or deeper analysis. Across the world, there are countless examples of geological formations that initially inspired speculation before being explained through careful study. Basalt columns in volcanic regions break into near hexagonal shapes as lava cools and contracts. Sandstone erodes in ways that produce flat surfaces and sharp edges. Salt deposits crystallize into repeating patterns that resemble engineered grids. Each of these processes follows physical laws that do not require intelligence. Yet the results can appear strikingly structured. This is one of the core challenges in understanding deep time. The Earth is capable of producing forms that mimic design without any underlying intent. Over millions of years, pressure, temperature, erosion, and chemical processes interact in ways that can create illusions of architecture. A cliff face may resemble a facade. A fractured plateau may appear like a ruined complex. But when examined layer by layer, these structures reveal no hidden continuity, no construction sequence, and no evidence of modification by intelligent agents. In archaeology and geology, context is everything. A single formation or object, taken in isolation, can be misleading. What matters is the surrounding matrix, the sediment in which it is embedded, the orientation of layers above and below it, and the microscopic traces left on its surfaces. Without this context, interpretation becomes vulnerable to perception rather than evidence. There have been cases where naturally fractured stones were initially thought to be tools or even architectural remnants, only to be reclassified after detailed analysis. Under magnification, natural fracture patterns lack the consistent wear and edge refinement expected from repeated use. Similarly, supposed walls formed by aligned stones often reveal themselves to be the result of erosion sorting materials by size and weight over time. Even more complex are cases where geological processes produce repeating geometric forms. Mineral veins can branch in fractal patterns that resemble engineered networks. Crystallization can generate symmetry that feels artificial in its precision. But unlike human design, these structures lack functional organization. They do not connect systems or serve purposes. They are simply the outcome of energy-seeking equilibrium. The human mind, however, is not neutral in its perception. It is deeply tuned to recognize order, especially in ambiguous environments. This ability has evolutionary advantages, allowing early humans to detect threats, tools, and patterns in nature. But in the context of ancient geological formations, this same instinct can lead to false impressions of design where none exists. This is particularly relevant when discussing claims of civilizations predating humanity. Many of these claims originate from visual interpretation rather than scientific verification. A symmetrical rock formation becomes a structure. A naturally eroded plateau becomes a city ruin. Once the idea takes hold, it can be difficult to separate perception from measurable evidence. Scientific investigation approaches these formations with a different methodology. Instead of relying on appearance alone, researchers examine composition, formation history, and microscopic structure. They test whether features align with known geological processes or whether they exhibit anomalies that cannot be explained through natural mechanisms. In nearly all documented cases, natural explanations prevail. This does not diminish the sense of wonder that such formations inspire. On the contrary, it highlights the complexity of natural systems. The Earth is capable of producing patterns that rival the appearance of intentional design without requiring any guiding intelligence. Over vast timescales, randomness filtered through physical laws becomes structured enough to resemble order. Even within human history, early tool-making adds another layer of complexity. Primitive stone tools, especially those from early Homo species, can look deceptively simple. Without proper analysis, it can be difficult to distinguish between a naturally broken rock and a deliberately shaped implement. Archaeologists rely on subtle indicators such as repeated edge wear, flake patterns, and standardized shaping techniques to make this distinction. This careful separation of natural and artificial is essential because it prevents overinterpretation of the archaeological record. Without it, nearly any unusual formation could be assigned human origin, especially in deep time contexts where familiarity is limited. In the broader sweep of Earth's history, natural forces dominate the record. Tectonic uplift creates mountain ranges that mimic monumental architecture. Erosion sculpts landscapes into forms that resemble pathways or structures when viewed from a distance. Sedimentary layering produces horizontal stratifications that can look like constructed terraces. Yet all of these arise without any guiding intelligence. As the study of geology advances, the tools for distinguishing between natural and artificial become increasingly precise. Microscopic imaging, isotopic analysis, and 3D mapping allow scientists to reconstruct the history of formations in detail far beyond visual inspection. These methods consistently reinforce the same conclusion. Earth's apparent structures in deep time are the result of natural processes operating over immense durations. Still, the fascination persists because it touches something fundamental in human cognition. The desire to find meaning in complexity is not an error, it is part of how understanding is built. But in the context of Earth's deep history, it must be balanced with the recognition that complexity does not always imply intention. As the surface of the planet continues to shift, erode, and reform, it becomes clear that what appears as structure is often the temporary outcome of forces that are still active today. The same processes that shape modern landscapes have been operating for billions of years, continuously rewriting the surface of the Earth. And within that endless rewriting, the idea of lost civilizations before humanity gradually loses support, not because imagination fades, but because evidence consistently points elsewhere. What remains is a deeper appreciation of how convincingly nature can imitate order, and how careful one must be when interpreting the language written in stone. Stories of ancient worlds often begin not in stone or bone, but in memory passed through language. Long before writing systems exist, human societies carry their understanding of the world through oral tradition. These stories shift with each telling, shaped by environment, fear, and the need to explain what lies beyond direct experience. In this space between memory and imagination, ideas of older worlds begin to form worlds that existed before the present order, sometimes described as broken. Submerged or erased, across different cultures, there are myths of great floods, vanished lands, and earlier ages that ended in catastrophe. In some traditions, these stories describe entire realms that were lost beneath rising waters. In others, they speak of previous cycles of humanity that were wiped away and replaced. While these narratives are rich and meaningful within their cultural contexts, they're not treated by modern science as literal accounts of pre-human technological civilizations. Instead, they are understood as symbolic frameworks built from real environmental experiences, especially dramatic climate and landscape changes. One of the most powerful influences on these stories is the end of the last ice age. As global temperatures rose, vast ice sheets that had covered large portions of the northern hemisphere began to melt. Sea levels rose significantly, reshaping coastlines around the world. Areas that were once dry land became submerged continental shelves. Rivers changed course. Coastal habitats disappeared beneath expanding oceans. For human populations living near these shifting environments, the changes would have been profound and often catastrophic. It is not difficult to imagine how such events could become preserved in oral tradition. A coastline that retreats generation after generation can feel like the world itself is being erased. Landmarks disappear beneath water. Migration becomes necessary. Entire ways of life must adapt or vanish. Over time, these lived experiences can transform into stories of great floods or lost homelands, even if the original causes are gradual rather than sudden. Archaeological and geological evidence supports the reality of significant sea level rise during this period. As ice sheets melted, global sea levels rose by more than 100 meters in some estimates. This process was not uniform or instantaneous, but it was large enough to permanently submerge vast regions that had once been habitable. Many of these regions are now under shallow seas, making direct archaeological investigation extremely difficult. These submerged landscapes are of particular interest to researchers today. Underwater archaeology has begun to reveal traces of ancient human activity along now drowned coastlines, stone tools, habitation sites, and other artifacts have been discovered beneath sediment layers offshore. These findings confirm that early human populations did inhabit areas that are now underwater, although they belong to known human history rather than any unknown pre-human civilization. What makes these discoveries compelling is not that they reveal lost advanced civilizations, but that they highlight how much of human prehistory is physically inaccessible. The shoreline is one of the most dynamic environments on Earth. It shifts constantly, eroding and rebuilding itself over thousands of years. Entire archaeological landscapes can be lost to the sea without a trace visible from land. This loss contributes to the sense that something might be missing from the historical record. When evidence is submerged or destroyed, gaps appear in the archaeological map. But these gaps are not necessarily indications of unknown civilizations. They are often the expected result of natural processes acting over time. Preservation is uneven. An absence in one location does not imply presence of something entirely different in another. Myths of earlier worlds often reflect this uneven relationship between memory and environment. A rising flood in a story may encode the memory of coastal inundation. A destroyed city may represent the loss of a real settlement to erosion, fire, or abandonment. A vanished land may correspond to regions now underwater or transformed beyond recognition. The symbolic language of myth preserves emotional truth even when the literal details change. At the same time, some modern interpretations of these myths extend them beyond what the evidence supports, suggesting literal pre-human civilizations that were erased without trace. From a scientific perspective, this interpretation is not supported by archaeological, genetic, or geological data. The timelines of human evolution, climate change, and sediment formation do not show signs of such civilizations existing before anatomically modern humans. Instead, what emerges from the combined evidence is a more grounded but still remarkable picture. Humans have lived through dramatic environmental changes. They have adapted, migrated, and rebuilt societies multiple times in response to shifting conditions. In doing so, they have left behind fragments of their existence that are unevenly preserved across the planet. Even within this grounded framework, uncertainty remains about many details of early human life. Some migration routes are still debated. Some cultural transitions are not fully understood. Some submerged sites have only been partially explored. But these uncertainties exist within a known biological and archaeological framework, not outside it. What makes myths of lost worlds so enduring is not their accuracy, but their resonance with human experience. They speak to a fundamental awareness that landscapes change and that human existence is fragile within those changes. Over time, this awareness becomes woven into stories that outlive the environments that inspired them. As modern science continues to explore submerged coastlines and ancient climate records, it finds not evidence of forgotten pre-human civilizations, but evidence of human resilience in the face of environmental transformation. The real lost worlds are not older civilizations hidden beneath history, but familiar human worlds erased by time and water, leaving only traces scattered across continents and sea floors. And in this realization, the idea of forgotten civilizations before humanity begins to fade, replaced by something more grounded but no less vast, a record of humanity itself stretched thin across a planet that never stops changing. The world that early humans inherit is not stable, not fixed, and never truly predictable. It shifts under cycles far larger than any single generation can perceive. Ice advances slowly across continents, grinding mountains into sediment, then retreats just as gradually, revealing landscapes that have not seen sunlight in tens of thousands of years. Rivers change course, lakes appear and vanish, and entire ecosystems migrate across latitudes as if the planet itself is breathing on a scale that exceeds human memory. These repeated Ice Age cycles are among the most powerful forces shaping the archaeological record, even though they leave no monuments in the traditional sense. Instead, they erase them. A site occupied for thousands of years can be buried under glacial deposits, scoured clean by ice, or submerged beneath meltwater lakes. Later warming phases may expose fragments again, but rarely in their original arrangement. The result is a deep time archive that is constantly being rewritten, not preserved. What remains visible today is only a thin fraction of what once existed. During colder periods, sea levels drop dramatically as water becomes locked in ice sheets. Continental shelves, now submerged, expand into vast exposed plains. These areas are likely where many early human populations lived, hunted, and migrated. When the ice melts again, those same regions disappear beneath rising seas, taking with them any traces of habitation that were not deeply buried or protected. This cycle of exposure and loss creates a fundamental challenge for understanding prehistory. The map of human origins is incomplete not because nothing existed, but because time has selectively erased large portions of it. Some regions preserve evidence well, such as caves or dry highlands. Others, especially coastal zones, are almost entirely lost beneath the ocean. It is within this framework that speculation about lost civilizations often emerges. If entire landscapes have been submerged or destroyed, it is tempting to imagine that something more structured might have been lost along with them. But the geological and archaeological evidence does not support the existence of technological civilizations in these time periods. What it does show is a continuous, if fragmentary, presence of human and pre-human life adapting to changing environments. Glacial activity is particularly effective at destroying surface evidence. Ice sheets behave like slow-moving bulldozers, dragging rocks, soil, and anything embedded within them across vast distances. When they retreat, they leave behind rearranged landscapes with little resemblance to their earlier form. Moraines, drumlins, and scoured bedrock tell the story of this movement, but they do not preserve fine details of human occupation unless those details were deeply protected. Even in regions not directly covered by ice, the indirect effects of glacial cycles are significant. Changes in sea level alter coastlines, forcing populations to relocate. Shifts in temperature and rainfall transform ecosystems, affecting food availability and migration routes. Rivers carve new paths, sometimes cutting through older sites and dispersing archaeological material across wide areas. Because of this constant environmental instability, preservation becomes the exception rather than the rule. Sites that survive tend to do so because of specific and unusual conditions: burial under volcanic ash, collapse into caves, or rapid sediment coverage. Without such conditions, most traces of habitation are gradually broken down and redistributed by natural processes. This is why the archaeological record of early humans appears sparse in some periods and regions. It is not a reflection of absence, but of survival bias in the materials themselves. Stone tools endure, but wood, fibres, and organic structures rarely do. Even bone can dissolve under certain soil conditions over long periods of time. Despite this fragmentation, the overall pattern remains consistent. Early human populations show gradual technological development over time, not sudden leaps into advanced complexity. Tool industries evolve slowly, reflecting incremental improvements in technique and adaptation. Fire use, hunting strategies, and social organization all develop within biological limits rather than technological frameworks. In contrast, the idea of advanced civilizations existing deep in the Ice Age or earlier would require evidence of sustained technological signatures: metals, refined materials, structural remains, or chemical anomalies in geological layers. None of these signatures appear in the relevant strata. The record remains biologically rich but technologically simple. Still, the imagination is often drawn toward the gaps: vast submerged regions, difficult to access cave systems, and heavily eroded landscapes leave room for speculation. But modern research continues to reduce these uncertainties through underwater archaeology, sediment core analysis, and improved dating techniques. Each new discovery tends to fill gaps with human migration and adaptation, not unknown civilizations. One of the most revealing aspects of Ice Age geology is how interconnected everything becomes when viewed over long timescales. Climate shifts influence ocean currents, which affect rainfall patterns, which in turn shape vegetation zones and animal migrations. Humans are part of this system, responding to changes rather than existing outside them. Their movements follow resources, and their technologies evolve in response to environmental pressure. This interconnectedness leaves a subtle but important signature in the archaeological record. Rather than isolated centres of development, there is a web of gradual expansion and adaptation. Cultural changes appear in waves that correlate with environmental shifts, not with sudden technological breakthroughs that would suggest lost industrial civilizations. Even so, the scale of change during glacial cycles can feel almost unimaginable. Coastlines move hundreds of kilometers. Entire land bridges appear and disappear, such as the connection between Asia and North America via Beringia. Populations expand into new territories during favorable periods and contract during harsher ones. Over thousands of years, this creates a constantly shifting mosaic of human presence. It is within this dynamic world that the absence of evidence for earlier civilizations becomes more meaningful. Despite repeated cycles of exposure and burial, erosion and preservation, no trace of pre-human technological complexity emerges. The patterns that do survive point consistently toward biological evolution and cultural development within human lineages. What the Ice Ages ultimately reveal is not hidden civilizations, but the fragility of the record itself. Time does not preserve evenly. It selects, distorts, and erases. And in that process, it can create the illusion that something is missing when, in fact, what is missing is simply what could not survive. As the planet continues its slow climatic rhythms even today, the legacy of those ancient cycles remains embedded in the ground beneath modern landscapes. They are reminders not of forgotten civilizations before humanity, but of a world that has always been in motion, reshaping the boundaries of life again and again. At the edge of retreating ice sheets, where meltwater begins to carve new channels through raw earth, the world does not look stable, it looks newly born. Vast plains emerge where thick glaciers once pressed down for thousands of years, and the land is still adjusting, still settling into shapes that will not remain fixed for long. Rivers cut unpredictable paths through freshly exposed sediment, carrying fine glacial flour into expanding seas. In these transitional spaces, time feels almost visible, written in shifting layers of mud, gravel and stone. As the Ice Age draws to a close in various regions, one of the most dramatic consequences is not just the melting of ice, but the global redistribution of water. Oceans rise steadily as massive ice sheets collapse, releasing trapped reserves back into the hydrological system. This is not a sudden flood in most cases, but a prolonged and relentless transformation that unfolds across generations. Coastlines migrate inland, sometimes by hundreds of kilometers, as shallow continental shelves disappear beneath expanding seas. These submerged shelves are among the most intriguing features of Earth's deep past. Today, they lie beneath relatively shallow waters, but during glacial periods they were exposed land, often vast, habitable plains rich in resources. Early human populations would have moved across these regions, following herds and seasonal cycles. When sea levels rose again, those landscapes were gradually lost beneath water, preserving only what had been deeply buried or sealed in sediment. The significance of this process is often misunderstood in popular imagination. The disappearance of these coastal plains does not imply the loss of unknown advanced civilizations, but rather the loss of ordinary human habitats that were never designed to endure geological timescales. Campsites, hunting grounds, and seasonal settlements were vulnerable to exactly the kind of environmental change that defines the end of the Ice Age. Underwater archaeology has begun to explore these drowned landscapes. In some regions, divers and remote sensing technologies have identified stone tools, hearth remnants, and modified landscapes now submerged beneath meters of water. These findings confirm that human activity once extended far beyond modern coastlines. However, they also reinforce a consistent picture these were mobile, adaptive populations, not urbanized civilizations. What makes these discoveries compelling is not their mystery, but their familiarity. The artifacts recovered from submerged sites are consistent with known prehistoric technology's simple tools, organic remains, and traces of temporary occupation. There are no signs of complex architecture, no evidence of large-scale engineering, and no materials that would suggest industrial activity. Still, the idea of lost coastal civilizations persists in cultural memory. Part of this comes from the sheer scale of what has been submerged. When entire landscapes disappear beneath the ocean, it is natural to imagine that something more structured might have been lost along with them, but geological and archaeological evidence consistently shows that these were regions of human presence, not centers of advanced technological development. The process of submergence itself is slow enough to allow for adaptation. As sea levels rise over centuries, populations tend to migrate inland rather than vanish suddenly. This movement leaves behind a trail of archaeological signatures that can sometimes be traced across continents. Settlement patterns shift, resource use changes, and new cultural adaptations emerge in response to changing environments. At the same time, erosion along coastlines continues to destroy evidence, wave action, sediment redistribution, and biological activity break down exposed materials rapidly. Even in modern times, coastal archaeology is one of the most challenging fields precisely because preservation conditions are so poor. Extending this reality back thousands of years makes it clear why so much has been lost. Despite this loss, the overall trajectory of human development remains visible. Genetic studies provide an additional layer of evidence, revealing how populations moved and diversified over time. DNA analysis shows repeated migrations out of Africa, across Eurasia, and into the Americas, all occurring within a framework of gradual adaptation rather than sudden appearances of unknown civilizations. These genetic patterns align closely with archaeological findings. Populations expand during favorable climatic windows and contract during harsher periods. Bottlenecks occur during environmental stress, followed by periods of diversification as conditions improve. This rhythm reflects biological survival rather than technological inheritance from unknown predecessors. Even when submerged landscapes are studied in detail, they continue to reinforce this pattern. Sediment cores extracted from ancient seabeds reveal pollen, microfossils, and chemical signatures that reconstruct past environments. These records show ecosystems supporting hunter-gatherer populations, not indicators of complex urban infrastructure. One of the most important insights from studying post-Ice Age sea level rise is how quickly perception can shift. A landscape that feels permanent within a human lifetime can vanish on geological timescales. Mountains remain, but coastlines do not. Rivers persist, but their paths change. Human settlements, unless continuously maintained or heavily constructed, are among the most vulnerable features of all. This vulnerability is central to understanding why the idea of pre-human civilizations is not supported by evidence. If relatively recent prehistoric sites are already difficult to preserve, then anything far older would be even more unlikely to survive in recognizable form. Over tens of thousands or millions of years, natural processes would erase almost all surface-level traces. And yet, even with this understanding, the emotional appeal of lost worlds remains strong. Submerged landscapes evoke a sense of absence that feels almost narrative in nature. It is easy to imagine cities beneath the waves, roads stretching across now invisible plains, entire societies erased without trace. But science consistently replaces these images with more grounded, though still remarkable, realities of human adaptation and environmental change. As sea levels stabilize in the later Holocene, new coastlines emerge that define the modern world. Human societies begin to shift toward more permanent settlements in certain regions, eventually leading toward agriculture and urbanization. But this development occurs long after the disappearance of the Great Ice Age coastal plains, marking a clear separation between prehistoric mobility and later civilization. The submerged world remains beneath the water, not as a hidden civilization, but as a record of a changing planet. It is a record written in drowned forests, buried river channels, and sediment layers slowly accumulating on ancient land surfaces. And in that record, what stands out most is not what is missing, but how consistently the evidence points back to the same conclusion: humanity's past is long, complex, and deeply tied to environmental change, but it does not extend into unknown technological civilizations hidden beneath the sea. There was a time when the Sahara was not a desert at all, but a vast green expanse shaped by seasonal rains, flowing rivers, and shallow lakes that spread across regions now defined by sand and silence. In this earlier climate phase, often referred to as the African humid period, the landscape supported grasslands, woodlands, and freshwater systems capable of sustaining a wide range of animal and human life. What is now one of the harshest environments on Earth was once a living corridor of movement and settlement. Within this transformed environment, early human groups and later pastoral societies followed the rhythms of water rather than scarcity. Lakes expanded and contracted with shifting rainfall patterns. River systems supported fishing and hunting. Herds of wild and later domesticated animals moved across regions that today appear completely uninhabitable. Rock art found across parts of the Sahara preserves glimpses of this world, depicting animals such as giraffes, cattle, and antelope in areas that are now entirely arid. These visual records are not evidence of lost civilizations in the technological sense, but they are powerful evidence of environmental transformation. The Sahara's shift from green to desert was not instantaneous. It unfolded over thousands of years as orbital changes gradually altered monsoon patterns across North Africa. Rainfall decreased, lakes shrank, vegetation receded, and desert conditions slowly expanded southward and northward until they merged into the vast arid region seen today. What makes this transformation particularly important for understanding human history is its scale. Entire lifeways had to adapt or migrate. Populations moved toward the Nile Valley, sub-Saharan regions, and other areas where water remained accessible. In doing so, they carried cultural knowledge, technologies, and traditions that would later contribute to the development of complex societies along stable water sources. Yet even in this well-documented environmental shift, misunderstandings sometimes arise. The presence of ancient rock art and abandoned lake beds has occasionally been interpreted as evidence of lost advanced civilizations. However, archaeological analysis consistently shows that these were pastoral and hunter-gatherer societies, not urban or industrial cultures. Their tools, settlement patterns, and material remains align with known prehistoric human development. The key factor here is continuity. The archaeological record of the Sahara shows gradual transitions in technology and subsistence strategies. Stone tools evolve over time. Evidence of animal domestication appears in later phases. Burial practices become more complex, but always within the framework of human-scale societies adapting to environmental change. There is no abrupt discontinuity that would suggest the rise or disappearance of an unknown technological civilization. Geological evidence supports this narrative. Sediment cores taken from ancient lake beds reveal layers of organic material, pollen, and microfossils that map the transition from humid to arid conditions. These records show a slow decline in vegetation rather than sudden ecological collapse. The shift is measurable and consistent with orbital forcing mechanisms, particularly changes in Earth's axial tilt and precession cycles that affect monsoon intensity. As water sources diminished, human populations concentrated around remaining reliable environments. The Nile River became a critical corridor of survival and cultural development. Other groups moved toward the Sahel and sub-Saharan regions, where seasonal rainfall still supported life. This redistribution played a major role in shaping later population patterns across Africa. One of the most significant insights from studying the Green Sahara is how dramatically environments can change within relatively short geological periods. Regions that once supported lakes tens of kilometers wide are now dry basins. Ancient shorelines are preserved as faint traces in the sand. Fossilized river channels lie beneath dunes, invisible without satellite imaging or subsurface scanning. Despite this dramatic transformation, the archaeological record remains consistent with known human behavior. There is no evidence of large-scale engineered infrastructure, no signs of complex urban planning, and no materials indicative of technological industry. Instead, what survives are traces of mobile or semi-sedentary populations responding flexibly to environmental stress. This pattern is important because it reinforces a broader understanding of human prehistory. Environmental change drives cultural change, but within the limits of biological and technological capability, societies adapt, migrate, and reorganize, but they do not suddenly leap into unknown forms of civilization without leaving detectable traces in the material record. Modern interpretations of ancient landscapes sometimes extend beyond what the evidence supports, suggesting hidden histories beneath the sand. However, remote sensing technologies, archaeological surveys, and geological studies have significantly reduced the likelihood of such hidden scenarios. The Sahara, in particular, has been extensively studied through satellite imagery, revealing subsurface features such as ancient riverbeds and settlement sites consistent with known prehistoric cultures. Even so, the sense of mystery persists, partly because the Sahara's transformation is so extreme. It is difficult to imagine that such a vast desert was once green and inhabited. This cognitive dissonance can create space for speculative interpretations, even when scientific evidence provides a coherent explanation. In reality, the Green Sahara is not a story of lost civilizations, but of environmental rhythm on a planetary scale. It demonstrates how Earth's climate system operates in cycles that reshape habitability across entire continents. Human societies are part of this system, not separate from it, moving in response to changes that occur over millennia. The rock art, fossil lakes, and buried river systems of the Sahara stand as reminders of this deep connection between climate and culture. They show that human history is not confined to stable environments, but unfolds across shifting landscapes that can transform dramatically over time. And within that transformation, the idea of forgotten advanced civilizations gives way to something more grounded but equally vast, a record of adaptation written in sand, stone, and water that no longer flows. In the long span of Earth's history, there are moments when the presence of large animals shapes not only ecosystems, but the way early humans experienced the world itself. Before modern climates settled into familiar patterns, much of the planet was shared with megafauna, giant mammals and other species that no longer exist today. These were not mythical creatures, but real animals adapted to Ice Age environments, some of them far larger than anything seen in the present. Mammoths moved across steppe-like plains in herds, their presence reshaping vegetation through constant grazing and migration. Giant ground sloths in the Americas occupied ecological niches that no longer exist. Saber-toothed predators hunted in ways that reflected both strength and specialization. In Eurasia, massive bison and rhinoceros species roamed open landscapes that supported complex food webs. For early human populations, these animals were not distant curiosities, but immediate realities that influenced survival strategies. The interaction between humans and megafauna is one of the most important chapters in prehistory. Evidence from kill sites, tool marks on bones, and preserved hunting grounds shows that humans did engage with these animals, sometimes as predators, sometimes as scavengers. But this interaction was never simple or one-sided. Megafauna also shaped human movement, limiting where groups could safely travel and influencing seasonal patterns of migration. In some regions, the disappearance of these large animals marks a major ecological transition. Many megafauna species went extinct toward the end of the last ice age, likely due to a combination of climate change and human activity. Though the exact balance between these factors is still debated, As environments warmed and habitats shifted, specialized cold-adapted species struggled to survive. At the same time, human hunting pressure may have contributed to the decline of certain populations. What is important in this context is that extinction events, while dramatic, do not imply the loss of technological civilizations. They reflect ecological imbalance and environmental change, not the collapse of unknown industrial societies. The fossil record shows clear biological continuity across this transition, with no interruption that would suggest artificial intervention or erased advanced cultures. Bone beds and fossil deposits from this period provide detailed evidence of how these animals lived and died. Cut marks on bones indicate butchery practices. Tooth wear patterns reveal diet. Isotopic analysis shows migration routes and seasonal behavior. These scientific methods reconstruct entire ecosystems with surprising clarity, even when the environments themselves have vanished. Occasionally, megafauna remains are discovered in conditions that preserve them almost intact, such as frozen mammoths in Siberia. These discoveries offer rare glimpses into Ice Age life, including preserved skin, hair, and even stomach contents. They reinforce the reality that these animals were part of a fully biological world, not symbolic or mythical constructs. Despite this clarity, megafauna often appear in modern storytelling as part of broader narratives about lost worlds or forgotten ages. Their enormous size and unfamiliar forms make them easy to mythologize. In earlier human cultures, bones of extinct animals were sometimes interpreted as remains of giants or legendary creatures. Without scientific frameworks, these interpretations were natural attempts to explain extraordinary findings. Today, however, paleontology provides a detailed and consistent explanation for these remains. Evolutionary processes, climate shifts, and ecological competition account for both the rise and extinction of megafauna species. These explanations are supported by multiple independent lines of evidence, including fossil distribution, genetic analysis of related species, and climate modeling. The extinction of megafauna also had significant consequences for human societies. In regions where large game disappeared, humans had to shift towards smaller animals, fishing, and plant-based resources. This transition contributed to changes in social organization and subsistence strategies. In some areas, it may have indirectly supported the later development of agriculture by encouraging more stable food production methods. Even in these transitions, there is no evidence of disruption that would suggest the loss of advanced civilizations. Instead, what emerges is a continuous adaptation of human societies to changing ecological conditions. Tools become more refined in some regions, while in others, mobility remains the dominant strategy. One of the most striking aspects of megafauna extinction is how quickly entire ecological systems can reorganize. When large herbivores disappear, vegetation patterns shift, predator populations decline or adapt, soil composition changes due to altered grazing pressure. These cascading effects demonstrate how interconnected life systems are, even without human intervention. In this context, the Earth's past appears not as a sequence of lost civilizations, but as a series of ecological transitions driven by climate and evolution. Each extinction event reshapes the structure of life, but leaves behind no evidence of technological societies being erased alongside biological ones. It is also worth noting that the fossil record is extensive enough to capture these transitions in detail. If industrial or technological civilizations had existed alongside megafauna or before humans, their signatures would be expected to appear in the same sediment layers that preserve these animals. No such signatures exist. Instead, What remains is a record of life responding to environmental pressure over long timescales. Species emerge, adapt, and disappear. Ecosystems expand and contract. Climate acts as a constant shaping force, influencing every level of biological organization. As human ancestors continued to evolve through this world, their survival depended increasingly on flexibility rather than specialization. This adaptability becomes one of the defining characteristics of the human lineage, allowing it to persist through multiple extinction events and environmental shifts. And within that persistence lies a quieter truth: the world of megafauna was not a lost civilization, but a living ecosystem, vast, complex, and entirely natural, gradually transformed by time into something more familiar to the present. Among the most persistent ideas surrounding deep human history are claims that certain objects or discoveries do not belong in their geological context. These are often referred to as out-of-place artifacts, suggesting that tools, structures, or materials have been found in layers of Earth that are far older than accepted human timelines would allow. At first glance, such claims seem to challenge the established understanding of prehistory, but when examined closely, they almost always reveal a different story, one grounded in misinterpretation, contamination, or natural geological processes. One common source of confusion comes from the complexity of stratigraphy itself. Sedimentary layers are not always perfectly sealed or undisturbed. Earthquakes can fracture and shift deposits. Water can carry objects downward through cracks. Animals can burrow and displace materials across layers. Even modern excavation techniques, if not carefully controlled, can introduce contamination that blurs the boundaries between different time periods. Because of this, context is not just important, it is everything. When an object is found outside of its expected layer, the first scientific response is not to assume an impossible origin, but to investigate how it arrived there. In nearly all documented cases, a natural or human-mediated explanation is found. A stone tool may have been redeposited by erosion. A metallic object may have filtered downward through soil disturbances. A modern item may have been mistakenly recorded as ancient due to excavation error. There are also cases where natural formations are mistaken for manufactured objects. Certain rock nodules, when broken, can resemble shaped tools or even metallic artifacts. Iron-rich concretions can form smooth, rounded shapes that appear artificially cast. Under certain lighting conditions, these can be misinterpreted as evidence of advanced technology embedded in ancient strata. However, chemical analysis consistently reveals their geological origin. A key principle in archaeology is reproducibility. A single unusual find is not enough to overturn established timelines. For a claim to be accepted, it must be supported by multiple independent discoveries, consistent stratigraphic context, and verification through different analytical methods. So far, no out-of-place artifact claim has met these standards in a way that would require rewriting human history. One frequently cited category involves extremely hard stone or metal-like objects allegedly found in ancient rock layers. When such claims are investigated, they typically resolve into known geological processes such as mineralization, where groundwater deposits minerals over time, gradually forming structures that can resemble manufactured materials. In other cases, modern objects are introduced into older layers through natural disturbance or human error. Another important factor is the scale of geological time. Earth processes operate over millions or billions of years, and even small disturbances can significantly alter the position of materials over long periods. A fracture in rock can become a pathway for later intrusion. Sediment layers can be folded, overturned, or reoriented by tectonic forces. making their original sequence difficult to interpret without detailed analysis. Modern archaeology relies heavily on multiple dating techniques to avoid these pitfalls. Radiocarbon dating is used for relatively recent organic materials. Thermoluminescence measures the last time minerals were exposed to heat or sunlight. Potassium-argon dating extends far deeper into geological time. When these methods are applied together, they provide a coherent timeline that has remained consistent across thousands of studies. Within this framework, the absence of technological signatures in deep prehistory becomes even more significant. If advanced civilizations had existed in ancient geological periods, they would have left behind durable traces, refined alloys, synthetic compounds, structural remains with consistent engineering patterns, or chemical anomalies in sediment layers. None of these are present in the record. Instead, what is consistently found are natural geological formations and evidence of biological activity. Even when unusual structures appear, detailed analysis traces them back to known processes. The Earth is capable of producing a wide range of complex forms without requiring intelligent design. This includes crystalline structures, layered formations, and erosion patterns that can appear deceptively artificial at first glance. It is also important to recognize the role of cognitive bias in interpreting ambiguous findings. Humans are pattern-seeking organisms. This ability is essential for survival, but it also means that the brain tends to impose structure on randomness. In the context of archaeology and geology, this can lead to overinterpretation of natural formations as artificial constructs. Scientific methodology is designed specifically to counteract this tendency. Peer review, replication of results, and interdisciplinary analysis all serve to filter out misinterpretations. While this process is not infallible, it has consistently prevented unsupported claims of ancient advanced civilizations from being accepted into the scientific record. Another factor that reinforces the current understanding is the continuity of biological evolution. The fossil and genetic records show a gradual progression of species over time, with no interruptions that would suggest external technological influence. Human evolution itself is well documented through transitional fossils and genetic evidence that traces ancestry through multiple hominin species. Even in cases where archaeological sites are difficult to interpret, additional data usually resolves ambiguity. Where patterns on tools reveal their function, residue analysis identifies materials processed by early humans. Spatial distribution of artifacts shows patterns of habitation and movement. These layers of evidence build a coherent picture that aligns with known human development. The idea of out-of-place artifacts often gains attention because it appears to offer a shortcut to mystery and isolated anomaly that seems to overturn established knowledge. But in science, isolated anomalies are not sufficient. They must survive repeated testing, independent verification, and contextual analysis. Without that, they remain interesting curiosities rather than evidence of lost civilizations. As research continues, new discoveries do expand understanding of human prehistory. Sites are found in previously unexplored regions. Submerged landscapes are mapped in greater detail. Genetic studies refine migration timelines. But all of these advances reinforce the same fundamental pattern. Human civilization emerges relatively late in Earth's history, preceded by long periods of biological and cultural development without technological industry. In the end, out-of-place artifact claims reveal more about human interpretation than about ancient civilizations. They highlight how easily perception can be influenced by expectation, and how important careful scientific analysis is in separating appearance from reality. And as the layers of Earth continue to yield their fragments of the past, the evidence remains steady, There is no hidden technological civilization buried in deep geological time, only the long, continuous story of a planet shaped by natural forces and the gradual rise of life within it. In the search for deep human origins, science does not rely on a single type of evidence. Instead, it builds its understanding from multiple independent methods that converge toward the same conclusions. Archaeology examines material remains. Geology reconstructs ancient environments. Genetics traces biological inheritance across generations. Chemistry reveals changes locked inside minerals and organic matter. Each discipline, on its own, is limited. Together, they form a system designed to distinguish reality from illusion in the deep past. One of the most important tools in this system is radiometric dating. By measuring the decay of unstable isotopes within rocks and organic materials, scientists can determine when a substance was formed or last altered. This allows for the construction of a timeline that stretches back billions of years. These methods have been repeatedly tested, refined, and cross-verified across countless samples from around the world. When applied to human history, these dating techniques consistently show a recent emergence of Homo sapiens in geological terms. Anatomically, modern humans appear roughly within the last few 100,000 years, while earlier hominin species extend further back but remain biologically, not technologically, distinct. Nowhere in this timeline do we find evidence of industrial activity predating humans, or any unknown technological lineage embedded in ancient strata. Genetic evidence strengthens this picture. The human genome contains a record of evolutionary branching that can be traced through shared mutations and inherited markers. By comparing genetic sequences across populations and related species, scientists can reconstruct migration patterns and divergence points. These patterns align closely with archaeological findings, showing gradual dispersal out of Africa and adaptation to diverse environments across the globe. If a technologically advanced civilization had existed prior to humans, its influence would likely appear in these genetic records indirectly. Environmental changes caused by large-scale industrial activity would leave detectable signatures in ice cores, sediment layers, and atmospheric chemistry. No such signatures exist in periods preceding known human civilization. Ice core samples from Antarctica and Greenland provide some of the most detailed continuous records of Earth's recent climate history. These cores contain trapped air bubbles that preserve ancient atmospheres, allowing scientists to measure greenhouse gas concentrations over hundreds of thousands of years. The data shows natural fluctuations driven by orbital cycles, volcanic activity, and solar variation, but no anomalies that would suggest industrial-scale emissions before humans. Similarly, deep-sea sediment cores reveal a continuous record of ocean chemistry and biological activity. These layers capture events such as volcanic eruptions, asteroid impacts, and climate transitions. Yet even in the oldest accessible layers, there are no chemical markers consistent with artificial industrial processes. The Earth's environmental record remains biologically and geologically coherent. Archaeology contributes another layer of confirmation. Excavations across multiple continents reveal a consistent progression of tool use, from simple stone flakes to more refined composite tools, and eventually to agriculture and urban development. This progression is not abrupt but gradual, with each stage building on earlier techniques. There is no evidence of sudden technological inheritance from an unknown earlier civilization. Even in regions with long human occupation, the stratigraphic record remains orderly. Layers correspond to known cultural periods. Artifacts align with expected technological capabilities of those periods. When anomalies do appear, They are typically explained through natural disturbance, redeposition, or modern contamination rather than unknown ancient industries. One of the strengths of modern science is its ability to correct itself through convergence. When multiple independent methods point to the same conclusion, confidence in that conclusion increases. Radiometric dating, genetic analysis, sedimentology, and archaeology all converge on a single narrative. Life on Earth has a long biological history, but technological civilization is a recent development within that timeline. This convergence is particularly important when evaluating extraordinary claims. Claims of the lost civilizations in deep prehistory would require not just one line of evidence, but many. They would need to appear in genetic records, geological formations, archaeological layers, and atmospheric chemistry. The absence of such multi-layered evidence is a significant factor in scientific interpretation. At the same time, science does not claim to know everything. There are still many unanswered questions about early human cognition, the development of language, and the precise pathways of migration. Some regions of the world remain underexplored archaeologically. New discoveries continue to refine understanding, but these refinements operate within an already well-established framework, not outside of it. Another important concept in scientific interpretation is falsifiability. For a hypothesis to be considered scientifically valid, it must be testable in a way that could potentially prove it wrong. The idea of an ancient pre-human technological civilization, as often presented, lacks this property because it does not specify measurable conditions that would clearly confirm or deny its existence. Without such criteria, it cannot be integrated into scientific methodology. In contrast, existing models of human evolution and environmental change make specific predictions that can be tested and refined. For example, they predict where certain fossils should be found based on migration routes, or how climate shifts should appear in isotopic records. When tested, these predictions consistently align with observed data. This does not eliminate mystery from Earth's history. It simply defines where mystery currently exists in a meaningful way. The origin of consciousness, the development of symbolic thought, and the emergence of complex language remain areas of active research. These questions are profound, but they are being explored within a biological and evolutionary framework supported by evidence. As the layers of evidence accumulate, the overall picture becomes increasingly stable. Human civilization emerges relatively recently, built upon a long foundation of biological evolution and environmental adaptation. Before that, Earth's history is filled with life, climate change, and geological transformation, but not with technological civilizations waiting to be rediscovered. What science offers is not the removal of mystery, but its redefinition. Instead of asking what civilizations might have been lost beyond the reach of time, the focus shifts toward understanding how complexity actually arises within natural systems. That shift reveals a different kind of wonder, one grounded not in hidden civilizations, but in the long, uninterrupted continuity of life and planet, interacting over immense scales of time. And within that continuity, the story remains consistent. The Earth preserves no evidence of forgotten technological worlds before humanity. Only the gradual unfolding of life toward increasing complexity within the limits of nature itself. Beneath the surface of human history, written in strands of biological code rather than stone or myth, lies another kind of record, one that does not erode in the same way as archaeological sites, but instead accumulates slowly through generations. Genetic evidence has become one of the most powerful tools for reconstructing the deep past, revealing patterns of movement, survival, and adaptation that no written record could ever preserve. Every human carries within their DNA a history far older than civilization itself. Small mutations, passed from parent to child over countless generations, form a branching map of ancestry. By comparing these patterns across populations, scientists can trace how groups separated, migrated, and adapted to different environments. These genetic signatures do not suggest sudden introductions from unknown civilizations, but rather gradual divergence shaped by geography and time. One of the most consistent findings in population genetics is the shared origin of modern humans. All evidence points toward anatomically modern Homo sapiens emerging in Africa, followed by waves of migration into Eurasia, Oceania, and eventually the Americas. These movements occurred over tens of thousands of years, driven by climate shifts, resource availability, and changing ecosystems. The genetic record aligns closely with archaeological and climatic data, forming a coherent timeline of expansion. If a technologically advanced civilization had existed before or alongside early humans, its influence would be expected to appear in genetic data indirectly. Large-scale environmental changes caused by industrial activity would leave detectable anomalies in mutation rates, population bottlenecks, or chemical exposure markers. However, no such anomalies are present in the relevant time periods. Instead, the genetic record reflects natural evolutionary pressures and demographic events consistent with known prehistoric conditions. Ancient DNA extracted from fossils has added remarkable detail to this picture. The genomes of Neanderthals, Denisovans, and other archaic human groups show interbreeding events with modern humans, revealing a complex web of interaction between closely related hominin species. These interactions leave measurable traces in modern populations, particularly outside Africa, where small percentages of archaic DNA persist in human genomes today. This interbreeding does not indicate the presence of unknown civilizations, but rather a branching evolutionary tree with occasional overlap between lineages. Each group adapted to its environment in different ways, but all remained within the biological boundaries of early human evolution. The genetic evidence consistently shows continuity, not disruption. Another important aspect of genetic research is the ability to estimate population sizes over time. Through a method known as coalescent analysis, scientists can infer how many individuals contributed to future generations at different points in history. These models show repeated bottlenecks during periods of environmental stress, such as ice age cycles, followed by expansions when conditions improved. This pattern matches what is known from climate records and archaeological evidence. What is striking in all of this data is the absence of any sudden genetic break that would suggest the replacement or disappearance of a technologically advanced population. Instead, the human lineage appears as a continuous evolutionary process, shaped by adaptation rather than interruption. Environmental DNA, extracted from sediments and ice cores, further reinforces this continuity. These samples capture traces of ancient ecosystems, including plants, animals, and microorganisms. They allow scientists to reconstruct entire habitats that existed thousands or even hundreds of thousands of years ago. Yet even in these detailed records, there are no signs of artificial genetic modification or industrial biological contamination predating known human activity. The stability of this genetic and environmental record is significant. It means that while Earth's surface has undergone dramatic transformations, the biological story remains internally consistent. Species appear, evolve, and disappear in ways that align with ecological pressures and evolutionary mechanisms. not external technological influence. At the same time, genetics also reveals how adaptable early humans were. Small genetic variations provided advantages in different environments, such as changes in skin pigmentation, metabolism, or altitude tolerance. These adaptations allowed humans to survive in a wide range of climates, from Arctic tundra to tropical forests. This flexibility became one of the defining characteristics of the species. It is this adaptability that sometimes fuels speculative interpretations about hidden histories. The idea that humans might have inherited traits from unknown advanced predecessors is occasionally suggested, but genetic analysis does not support this. All observed traits can be traced through known evolutionary pathways shared with other hominins and primates. The strength of genetic evidence lies in its redundancy. Multiple independent studies across different populations, using different methods, consistently produce the same broad conclusions. Human ancestry is deep, but it is continuous and biologically grounded. There is no hidden genetic signature pointing toward lost technological civilizations. Even as technology advances and sequencing becomes more precise, the underlying narrative remains stable. New discoveries refine details but do not overturn the core structure of human evolutionary history. Instead, they add resolution to a picture that is already remarkably coherent. This coherence extends beyond humans to all life on Earth. Comparative genomics shows shared ancestry between species across vast evolutionary distances. The tree of life is interconnected, branching gradually over billions of years. Within this framework, humanity is one relatively recent branch, not the product of an unknown external lineage. As genetic science continues to develop, it increasingly integrates with archaeology and geology to form a unified understanding of the past. Fossils, artifacts, climate records, and DNA all point in the same direction: a long, continuous history of life shaped by natural processes, without evidence of earlier technological civilizations embedded within it. And within that continuity, the genetic record stands as one of the most precise tools available for understanding deep time. It does not reveal lost civilizations before humanity, but it does reveal something equally profound: the uninterrupted thread of life stretching back through time, connecting every living human to ancient populations who navigated a world in constant transformation. Hidden beneath modern oceans lies a world that once formed the edges of human experience. During periods of lower sea level, vast stretches of what are now continental shelves were exposed as dry land. These areas were not marginal or insignificant. They were often wide, fertile plains crossed by rivers, lakes, and seasonal migration routes. As the last ice age ended and waters slowly rose, these landscapes were gradually swallowed, transforming familiar terrain into submerged memory. Unlike dramatic flood narratives found in myth, this process was slow in most regions, unfolding over thousands of years. Coastlines retreated gradually, sometimes only a few meters per century, but over time this shift was enough to erase entire regions of human habitation. What remains today lies beneath shallow seas, often buried under layers of sediment or reshaped by marine currents. Modern marine archaeology has begun to uncover traces of this drowned world. In certain coastal zones, researchers have identified stone tools, hearth remnants, and modified landscapes preserved beneath seabeds. These findings confirm that early human populations lived far beyond today's shorelines, taking advantage of resources that existed on exposed continental shelves. However, these discoveries remain consistent with known prehistoric cultures, not evidence of unknown advanced civilizations. One of the most significant submerged regions is the area once known as Doggerland, which connected parts of present-day Britain and mainland Europe. This landscape supported forests, rivers, and wildlife before being gradually submerged by rising seas. Archaeological evidence from surrounding regions suggests that human groups moved through this area extensively before its final disappearance beneath the North Sea. Similar submerged landscapes exist around the world, including parts of the South China Sea, the Persian Gulf, and the coastlines of the Americas. In many of these regions, underwater surveys have revealed channels of ancient rivers, submerged dune systems, and traces of prehistoric human activity. These findings dramatically expand the known map of early human habitation, but they remain within the framework of mobile, adaptive societies rather than urban civilizations. The challenge in studying these landscapes is not only their depth, but their transformation. Once submerged, coastlines are subjected to constant erosion, sediment deposition, and biological activity. Over time, structures degrade, materials disperse, and clear architectural features become difficult to identify. Even relatively recent shipwrecks can be heavily altered within centuries, making deep time preservation extremely rare. This process explains why submerged prehistoric sites are often fragmentary. Tools may be scattered by currents. Organic materials decay rapidly unless buried in oxygen-poor conditions. Sediment layers can obscure or distort original site layouts. As a result, underwater archaeology requires careful interpretation and multiple lines of evidence to reconstruct past environments. Despite these difficulties, the data gathered so far consistently supports a picture of human adaptation to changing coastlines. Populations followed shifting resources, relocated settlements, and adjusted subsistence strategies in response to rising seas. There is no indication of sudden disappearance or abrupt technological collapse beyond known environmental pressures. Genetic and archaeological evidence together reinforce this narrative. Migration patterns show movement away from coastal regions during periods of rising sea levels. Cultural artifacts demonstrate continuity across inland and coastal populations. These patterns align with expected responses to environmental change rather than unexplained disruptions. It is within the scale of these submerged landscapes that speculation about lost civilizations often emerges. The idea is intuitive if entire regions are now underwater. Perhaps advanced societies once existed there and were erased. However, this hypothesis does not align with the evidence recovered so far. The material remains found beneath the sea correspond to known prehistoric technologies, not to industrial or urbanized systems. No submerged structures have been found that exhibit the engineering complexity associated with technological civilizations. No artificial materials, no advanced alloys, no large-scale architectural networks. Instead, the remains reflect the lifeways of hunter-gatherers and early agricultural communities transitioning between environments. The importance of these submerged landscapes lies not in what they conceal, but in what they reveal about the fragility of human settlement. Even relatively recent prehistoric environments can be dramatically altered or erased by natural processes. This makes the preservation of older, more complex civilizations, if they had existed, extremely unlikely without clear and durable material signatures. Sea level rise after the Ice Age also reshaped global patterns of human distribution. As coastal plains disappeared, populations were forced into more concentrated regions. River valleys and inland areas became focal points of settlement. Over time, this concentration may have contributed to the development of agriculture and more permanent habitation structures. These changes mark a transition from highly mobile lifeways to increasingly sedentary societies. But this transition is gradual and well documented. it does not reflect the disappearance of a prior technological age, but rather the emergence of new social and environmental adaptations within the existing human lineage. One of the most striking aspects of studying submerged landscapes is how much they expand the scope of human prehistory without altering its fundamental structure. The map of early human life becomes larger, more complex, and more dynamic, but it remains consistent with evolutionary and archaeological evidence gathered on land. The drowned coastlines of the world are not ruins of unknown civilizations. They are extensions of known human history, preserved in fragments beneath layers of water and sediment. They remind us that Earth's surface is not static, and that entire chapters of human experience can be hidden simply by the movement of oceans. And in that realization, the idea of forgotten civilizations before humanity gives way once again to something more grounded, a long, continuous human story shaped by rising and falling seas, where what is lost is not mystery civilizations, but familiar worlds slowly erased by time and water. In the span of Earth's existence, civilization is not a constant feature, it is a late arrival. For billions of years, the planet exists without anything resembling cities, writing, or technology. Life emerges early in microbial form, slowly diversifies, and spends most of its history in biological complexity rather than cultural or technological complexity. Only in the most recent fraction of geological time does anything like civilization appear. This perspective changes how human history is understood. Agriculture, writing systems, and urban centers do not represent the culmination of an ancient, repeating cycle of civilizations. Instead, they represent a relatively recent transformation in a long biological story. For most of Earth's timeline, there are no humans at all, and for even more of it, there is no life capable of forming societies in the modern sense. The archaeological record supports this clearly. The earliest evidence of agriculture appears only around 10,000 years ago in multiple regions, emerging independently as humans begin to settle and domesticate plants and animals. Before that, human societies exist for hundreds of thousands of years as hunter-gatherers, adapting flexibly to environmental changes without permanent urban structures. This suddenness, in geological terms, often creates the illusion that something must have come before an earlier cycle of civilization that rose and vanished without trace. But this impression is not supported by physical evidence. Instead, what appears as sudden emergence is better understood as the result of cumulative cultural evolution, reaching a threshold where permanent settlements become possible. The materials left behind by early civilizations are also highly diagnostic. Writing systems, metallurgy, large-scale construction, and organized waste deposits all leave clear signatures in soil and rock layers. These signatures persist for thousands, or even tens of thousands of years depending on conditions. In deeper geological layers, none of these signatures exist. If earlier technological civilizations had existed and disappeared entirely, they would still be expected to leave detectable traces. Industrial activity produces distinct chemical markers, including metal enrichment, synthetic compounds, and isotopic anomalies. Even after structures decay, these signatures remain embedded in sediment and ice records. Yet across all studied deep time layers, such signatures are absent. Instead, what the record shows is a consistent transition from biological to cultural complexity within a single lineage. Early hominins develop stone tools. Later species refine those tools. Eventually, symbolic thought and communication systems emerge, followed by agriculture and urbanization. Each stage builds on the previous one without requiring external intervention or unknown predecessors. This continuity is reinforced by environmental evidence, climate fluctuations, recorded in ice cores and sediment layers, show repeated cycles that influence human development. During stable climatic periods, populations expand and technologies diversify. During unstable periods, societies contract or migrate. These patterns align closely with known human behavior rather than unexplained disruptions. One of the most important insights from this long view of history is how recent civilization actually is. Compared to the age of the Earth, or even the age of anatomically modern humans, urban civilization occupies an extremely small window. If Earth's history were compressed into a single day, civilization would occupy only the final seconds before midnight. This perspective naturally invites speculation about earlier civilizations that might have existed and disappeared. But speculation alone cannot replace the absence of evidence. Science relies on physical traces, materials, structures, and chemical signatures that persist across time. Without these, hypotheses remain ungrounded. Even in environments where preservation is exceptionally good, such as frozen regions or deep caves, there is no evidence of technological civilizations predating known human history. Instead, what is found are biological remains, stone tools, and gradually evolving cultural artifacts. The record remains consistent across continents and climates. The emergence of agriculture is particularly important in this timeline. It represents a fundamental shift from reliance on wild resources to controlled production of food. This transition allows for population growth, permanent settlements, and eventually complex societies. But it occurs independently in multiple regions, driven by environmental conditions and human innovation, rather than inheritance from unknown predecessors. Urbanization follows much later, arising in regions with stable water sources and fertile land. Cities such as those in Mesopotamia, the Indus Valley, and ancient China develop administrative systems, writing, and architecture. These developments leave clear and durable archaeological signatures that are easily identifiable in the geological record. No equivalent signatures exist in deeper layers of Earth's history. This absence is not a gap waiting to be filled, but a consistent pattern supported by multiple independent lines of evidence. It indicates that technological civilization, as currently understood, is a recent phenomenon within the broader timeline of life. What makes this realization powerful is not that it removes mystery, but that it reframes it. The question is no longer about lost civilizations hidden in deep time, but about how complex societies emerge at all within a relatively short evolutionary window. That process, from biological evolution to symbolic thought to organized civilization, remains one of the most remarkable developments in Earth's history. As the long arc of prehistory approaches the present, the continuity becomes clearer. There is no break in the record, no hidden technological predecessor, no erased industrial age buried beneath geological layers. Instead, there is a gradual unfolding of capability within a single lineage of life adapting to a changing planet. And within that unfolding, civilization appears not as a recovered legacy from forgotten ages, but as a new and fragile expression of intelligence that has only recently emerged on a very old world. When the view pulls back far enough, Earth stops looking like a collection of isolated events and instead becomes a continuous, shifting system where everything is in motion. Mountains rise only to be worn down again. Seas advance and retreat across continents. Forests expand, collapse, and reform in new configurations. Life follows these changes, adapting in ways that leave behind traces scattered across stone, ice, and sediment. Nothing remains fixed for long in this scale of time. Within this immense movement, human civilization appears as a very recent layer, resting on top of a much older biological foundation. The tools, cities, and cultural systems that define modern life are not inherited from unknown earlier technological ages, but built step by step through gradual accumulation of knowledge and adaptation. Every stage of this process is visible in the archaeological and genetic record, even if many details are still being refined. What makes deep time so difficult to intuit is not its size alone, but its continuity. There is no clear boundary where one world ends and another begins. Instead, there are slow transitions, climate shifting, species evolving, landscapes transforming. Even extinction does not create abrupt silence. It reshapes ecosystems into new forms. In this context, the idea of entirely erased technological civilizations becomes less plausible, not because imagination is limited, but because the physical record does not show the necessary discontinuities. If such civilizations had existed, their presence would not disappear cleanly. Industrial activity, construction, and large-scale energy use leave signatures that persist long after structures collapse. Chemistry embedded in sediments, isotopic shifts in ice, and durable synthetic materials would remain detectable across geological time. Yet in every examined layer older than human civilization, these signatures are absent. The record is not ambiguous in this respect. It is consistent. Instead, what persists across all lines of evidence is a story of gradual emergence. Life develops complexity over billions of years. Nervous systems evolve, then cognition, then symbolic thought. Humans appear as one branch of this long evolutionary tree, and only much later does civilization arise from accumulated cultural innovation. Nothing in this sequence suggests interruption by an earlier technological age. Still, the sense of mystery does not disappear. It simply shifts focus. Rather than asking what civilizations might have been lost, the more grounded question becomes how a species capable of reflection and abstraction emerges at all from purely biological beginnings. That transition from chemistry to consciousness, from survival behavior to symbolic culture, remains one of the deepest subjects of scientific inquiry. As modern research continues, new methods refine this understanding further. Improved dating techniques, expanded genetic sampling, and deeper ocean exploration all add resolution to the same underlying framework. They do not reveal hidden civilizations beneath ancient strata, but they do reveal increasingly detailed patterns of migration, adaptation, and environmental change. Even the most remote and inaccessible parts of the planet reinforce this consistency. Deep ocean sediments, Antarctic ice cores, and ancient cave systems all preserve records that align with known timelines. Where data is scarce, it is due to preservation limits, not evidence of erased technological societies. The planet's archive is incomplete, but it is not contradictory. The idea of forgotten civilizations before humanity often arises from the imagination trying to fill these gaps. Vast timescales, lost coastlines, and eroded landscapes can create the impression that something must be missing. But when each layer of evidence is examined, the same pattern reappears: biological evolution followed by gradual cultural development without signs of earlier industrial complexity. What remains after this long examination is not a diminished sense of wonder, but a different kind of depth. Civilization is not less mysterious because it is recent. It is more remarkable precisely because it emerges from a long and indifferent planetary history. A world that spent billions of years without cities or writing eventually produces beings capable of remembering that history. In the end, the Earth does not preserve evidence of forgotten technological civilizations before humanity. What it preserves instead is something more subtle and more enduring, a continuous record of change, adaptation, and emergence written across stone, ice, water, and living DNA. And as the perspective settles into this long continuity, the final image is not of lost civilizations buried beneath time, but of a single evolving world, ancient, active, and still unfolding, within which humanity is only the most recent expression of a much older story.